Okay, so we're going to talk here about light. So we're going to talk about the characteristics of light. So if you remember our previous topic about waves, I posted a video explaining the different kinds or types of waves. So we have here mechanical wave. We have two basically. We have mechanical wave and we have what do you call this one? Electromagnetic waves. Okay, so yung light class is actually a wave. Okay, so it's actually a wave and it's in the electromagnetic spectrum. Mamaya, mahalalaman natin kung ano yung electromagnetic spectrum. Okay pa? So, So, we go inside the electromagnetic waves and that is included yung light natin. Okay, so yun na muna yung maging focus natin ng discussion ngayon kasi yun yung cover ng inyong exam. Okay pa? So we're going to talk here about its characteristics, how light is being perceived by a person, and ano yung description ng light in physics or in science. Okay pa? So let's continue with the presentation. Okay, so yan. So I just want you class to know electromagnetic spectrum. Pag sinabi natin class electromagnetic spectrum, or it's a spectrum that contains range of electromagnetic waves. Okay? If you remember the different electromagnetic waves, okay, so from the video I posted in your Schoology, that contains several waves, or you call this electromagnetic waves. Okay? So, and these waves, for example, radio wave, we have microwave, we have infrared, visible light, ultraviolet, okay, so X-ray and gamma ray. So it is a range from lowest to highest frequency. Okay? So this particular topic is also grounded to the topics about waves. Kasi if you don't understand the topic about waves, okay, the different characteristics of a wave like frequency, like wave, like crest, something like that, you will not totally understand this topic. So it's a range from lowest to highest frequency. Remember class that frequency is the number of cycle or waves for a particular time, for example 1 second. So remember that. Okay pa? So yan. So another thing, so ito yung electromagnetic spectrum. Let me show that to you. Okay? So there are different electromagnetic waves. So we have here, for example, if you can see, okay, if you can see in my cursor, so we have radio waves, we have microwave, we have infrared, we have visible, so ito yung visible light that we can see colors, we have ultraviolet waves or radiation, we have X-ray, so we have also gamma ray. So if you notice that this electromagnetic spectrum contains wave which has a different or varying frequencies. Okay? From radio, it has a lowest frequency among the waves and increasing until the gamma ray which has the highest frequency. Okay? So I want you to remember first the frequency. When we speak of frequency, it's the number of cycle or waves passing through a given period or time. Okay po? So, or 1 second, for example. Okay? So, also, this particular spectrum or electro or EM spectrum, you call also that as EM spectrum. There are, aside from frequency that is given, kasi di ba, 10 raised to 4 hertz as the unit of frequency, okay, until to the 10 raised to 20 hertz as the unit of frequency of gamma ray. Okay, aside from the frequency, it's also given the what? It's also given the wavelength. Okay, when we speak of wavelength, it's the distance, if you remember the previous topic. It's the distance from crest of crest to crest. Okay, remember that. Crest to crest or trough to trough. So that's what we mean by wavelength. Okay, it's also given here that radio 10 raised to 3 has the highest, has the longest wavelength as compared to the gamma ray, which only contains 10 raised to the negative 2 meter. Okay, so wavelength here is measured in meter. Okay, do not forget. Okay, so aside from wavelength and frequency, we have here approximation of the wavelength. Gaano ba, anong tawag dito? Gaano ba kahaba, okay, yung wavelength ng particular EM wave. So for example here, radio wave can have a length as long as or as tall as the buildings. So yan po yung ibig sabihin yan. So approximation lang naman yan, not necessarily not necessarily ganun kahaba, but this particular length of this EM wave falls under this particular example. So for here, we have butterfly. So for infrared, so andyan tayo sa tip ng needle point. Okay, so for visible light, so yan yung niya, yung frequency or yung wavelength niya. So for protozoa 1. Okay, so molecules naman yung sa ultraviolet. So that's how small the wavelength of a particular ultraviolet wave. So 10 raised to negative 8 molecule. We have also here X-ray, which has a wavelength to approximate length of an atom, okay, or width of an atom. Okay, 10 raised to negative 10 meter. We have also here gamma ray, okay, atomic nuclei. So that's the smallest one, okay? So that's just a approximation. Also, aside from frequency, wavelength, and scale, we have here temperature. Okay, so a temperature of which of object at which this radiation is the most intense wavelength emitted. So anyway, for our discussion, we are not going to focus at the temperature level. Okay, so dito lang tayo mag-focus sa frequency and sa wavelength because that's part of our previous topic, characteristic of a wave. Okay, so let's continue. Remember class, from lowest to highest, you memorized radio wave, microwave, infrared, visible light, ultraviolet, X-ray, and gamma ray. So, we have 7, okay, in total EM wave. Okay po? So, if I ask you, or if the question in exam, okay, is composed like this one, for example, arrange the EM waves from lowest to highest. So, you are going to recite radio, or you are going to write radio to gamma ray. But if I ask you from lowest, highest to lowest frequency, you are going to write gamma to radio wave. Did you understand what I mean with this? Okay, so remember class that wavelength and frequency are inversely proportional to each other. The higher the frequency, the lower its wavelength. Okay, so remember that is inversely proportional. Okay, so let's continue. Okay, so let's talk each EM wave in a spectrum. So let's start first with radio wave. So it has the lowest frequency. Okay, lowest frequency and longest wavelength among the EM waves. So it carries the least energy among all other electromagnetic waves. Kasi energy, as you remember, okay, energy carries a particular a wave carries a particular energy, and the amount of energy depends upon the frequency of a wave. The higher the frequency, the higher the energy it carries. The lower the frequency, the lower the energy it carries. Okay po? So, kung ang radio wave and frequency are inversely proportional to each other, energy and frequency are directly proportional to each other. Meaning, if one increases, the other one will also increase. Okay po? So, yan. Radio waves can be applied in radio frequency, yung ginagamit natin sa mga radio frequency, okay, radio frequencies. Okay pa? So radio waves are used in radio broadcast and communication. Okay, we use radio wave in radio communication like cell phone, etc. Okay? So next in line we have microwave as the second from the lowest frequency in a EM wave. So it's used in transmitting or receiving signals in cellular phones. Receiving and transmitting signals. Okay? So it is used in cooking or heating food by means of microwave ovens. So kaya yung pangalan na microwave ovens come from the microwave because it used microwave as to heat food. Okay po? So, as a material in microwave oven. Okay, so that's microwave. Next, we have infrared. So, it occurs at frequencies above those microwaves and just below the red visible light. Okay, kasi mamaya, yung visible light it's not actually a one band, but it contains several bands of colors. Okay? 7 to be exact. So it's used in remote controls, yung infrared. So remember that these EM waves have practical applications. Okay po? So, yan. Okay, so for visible light, so after infrared, we have visible light. So remember class that visible light, it's the only EM wave that we can see, okay, or it's the only wave that our eyes can see. So it's the only part of electromagnetic spectrum that can be detected by the human eye, okay. So since it can be detected by the human eye, it can varies from it can be described by different colors like this one, red, orange, yellow, green, blue, violet. So these are combinations of different colors that actually exist in our world. Okay po? So it is composed of 6 colors with different wavelengths. 6 colors with different wavelengths. But sometimes in other references, it contains 7 because there is an added, added color indigo. Okay, are you familiar of the acronym ROY-G-BIV? Are you familiar of that, ROY-G-BIV? It was since in your elementary. Hindi sa inyo naturo yung acronym na ROY-G-BIV? Hindi sa inyo naturo? Okay. So anyway, we're going to have that particular acronym here. Okay, so ROY-G-BIV stands for the different bands of color of visible light. Okay, so ROY-G-BIV, if you are going to recite the color, so red, R for red, O for orange, we have yellow, Y, we have green, G, B, blue, we have violet. Okay, so if you read this particular acronym, you pronounce at ROY-G-BIV. Sometimes in between violet and blue, included dyan yung indigo. Okay po, kaya yan yung ROY-G-BIV. Ano yung arrangement niya? ROY-G-BIV from, tignan nyo kasi class, ROY-G-BIV from lower frequency to the highest frequency. Lowest, which is red frequency, violet, highest frequency. Pero kapag VIBGYOR, that's the opposite of ROY-G-BIV. So it's from highest frequency to a lowest frequency. Okay po? So, yan. So it's composed of 6 colors with different wavelengths. Wavelength is measured in nanometer. Okay? So nanometer na po yung measurement niya kasi it's as smallest as the meter. Okay po? Shortest rather. Okay, so let's come next to ultraviolet, next to visible light. Ultraviolet is a wave that hindi na natin nakikita. Remember that among the 7 EM waves, only the visible light is yung nakikita natin. So it's commonly emitted by the sun. Commonly, okay? Commonly emitted by the sun, has shorter wavelength because it corresponds to higher frequency. Okay po? Then violet light thus has higher frequency. Kasi if you're going to look at this EM wave, EM spectrum, balikan natin yung spectrum. Okay, kung makikita nyo class sa visible light, it's here in this portion. The rest, black na siya kasi hindi na siya nakikita ng ng mata. Okay? So, yung may color lang yung nasa gitna and that is the visible light. If you're going to look at this one, red is on the left portion, which means it has lowest frequency, longer wavelength. Violet is on the right side of the spectrum. That means it has higher frequency, shorter wavelength. Okay, so therefore, next to violet, which is at the rightmost part of the visible light spectrum, is the ultraviolet. Okay, kaya it is said here that it has shorter wavelength. Shorter wavelength corresponds to higher frequency than the violet light. So thus has higher frequency. Okay pa? So I hope you're getting what I mean with this one. Okay? So next, do you have any question first to ask?
Wala po.
Wala. Okay, so next. Okay, so after ultraviolet waves, we have X-ray. So remember that X-ray, it's very common word from you because it can it can penetrate soft tissues of our body. Okay, nadidetect niya kung yung tao may tumor or yung fracture sa bone kasi yon, nagpe-penetrate yung X-ray sa soft tissues ng ating body. So two types, we have soft and hard, which differ in photon energies. Photon energy or the energy it transmits. Okay? So soft X-rays have photon energies from about 100 to 10,000 electron volts per 1 photon. So, yan. Hard X-rays have higher energy than soft. Okay? Hard has higher energy than soft. It can penetrate through matter. Ito na yung hard X-ray na even your bone can penetrate na yung hard X-ray. Pero yung soft X-ray, yan lang po yung classification niya. Okay? So, X-rays are used in medical imaging. So, next, after X-ray, we have here gamma ray. Gamma ray is among all the EM waves has the highest frequency, which means shorter wavelength. So these rays fall in the range of electromagnetic spectrum above soft X-ray, just above soft X-ray, and almost in the range of hard X-ray. So medyo nag-overlap yung gamma ray and hard X-ray kasi yun, when it comes to the energy. Hard X-ray has higher energy carried than soft X-ray, but gamma ray has the highest energy carried than the hard X-ray. Okay? So, it's used to treat cancer by means of radiation therapy. Ito na yung ginagamit natin. Pag sinabing radiation therapy, gumagamit na tayo class ng gamma ray. Okay? Gamma ray para tunawin yung mga cancer cells. Okay po? And this radiation therapy can have several negative effects because it can also penetrate not only the cancer cells but also the cells that are good in your body. Okay po? So, gamma rays. Okay? So, before we go to the light as our main topic for today, I'm going to give you a video which will show the characteristics of a different different electromagnetic waves. Okay pa? So, let me play that first. Okay, so yan. So I'm going to play this one. This one will give you a summary of what we have talked here and probably more information that we did not cover in our discussion. Okay? I want you to listen here because this one is a good video presenting the different electromagnetic waves. Okay po? So let me play this one. So here is the video. So please listen to the content of this video.
Something surrounds you, bombards you, some of which you can't see, touch, or even feel. Every day, everywhere you go. It is odorless and tasteless, yet you use it and depend on it every hour of every day. Without it, the world you know could not exist. What is it? Electromagnetic radiation. These waves spread across a spectrum from very short gamma rays to X-rays, ultraviolet rays, visible light waves, even longer infrared waves, microwaves, to radio waves which can measure longer than a mountain range. This spectrum is the foundation of the information age and of our modern world. Your radio, remote control, text message, television, microwave oven, even a doctor's X-ray, all depend on waves within the electromagnetic spectrum. Electromagnetic waves, or EM waves, are similar to ocean waves in that both are energy waves. They transmit energy. EM waves are produced by the vibration of charged particles and have electrical and magnetic properties. But unlike ocean waves that require water, EM waves travel through the vacuum of space at the constant speed of light. EM waves have crests and troughs like ocean waves. The distance between crests is the wavelength. While some EM wavelengths are very long and are measured in meters, many are tiny and are measured in billionths of a meter, nanometers. The number of these crests that pass a given point within 1 second is described as the frequency of the wave. One wave, or cycle, per second is called a hertz. Long EM waves, such as radio waves, have the lowest frequency and carry less energy. Adding energy increases the frequency of the wave and makes the wavelength shorter. Gamma rays are the shortest, highest energy waves in the spectrum. So, as you sit watching TV, not only are there visible light waves from the TV striking your eyes, but also radio waves transmitting from a nearby station, and microwaves carrying cell phone calls and text messages, and waves from your neighbor's Wi-Fi, and GPS units in the cars driving by. There is a chaos of waves from all across the spectrum passing through your room right now. With all these waves around you, how can you possibly watch your TV show? Similar to tuning a radio to a specific radio station, our eyes are tuned to a specific region of the EM spectrum and can detect energy with wavelengths from 400 to 700 nanometers, the visible light region of the spectrum. Objects appear to have color because EM waves interact with their molecules. Some wavelengths in the visible spectrum are reflected and other wavelengths are absorbed. This leaf looks green because EM waves interact with the chlorophyll molecules. Waves between 492 and 577 nanometers in length are reflected, and our eye interprets this as the leaf being green. Our eyes see the leaf as green, but cannot tell us anything about how the leaf reflects ultraviolet, microwave, or infrared waves. To learn more about the world around us, scientists and engineers have devised ways to enable us to see beyond that sliver of the EM spectrum called visible light. Data from multiple wavelengths help scientists study all kinds of amazing phenomena on Earth, from seasonal change to specific habitats. Everything around us emits, reflects, and absorbs EM radiation differently based on its composition. A graph showing these interactions across a region of the EM spectrum is called a spectral signature. Characteristic patterns, like fingerprints within the spectra, allow astronomers to identify an object's chemical composition and to determine such physical properties as temperature and density. NASA's Spitzer Space Telescope observed the presence of water and organic molecules in a galaxy 3.2 billion light-years away. Viewing our Sun in multiple wavelengths with the SOHO satellite allows scientists to study and understand sunspots that are associated with solar flares and eruptions harmful to satellites, astronauts, and communications here on Earth. We are constantly learning more about our world and universe by taking advantage of the unique information contained in the different waves across the EM spectrum.
Okay, so yan. So that video explains all the characteristics of each EM waves. Okay po? So make sure that you find time to review if hindi nyo man na-absorb lahat ng information na sinabi dun sa video. But I'm going to post this one again in your Schoology then. Okay, so it's a good video explaining the EM waves, or especially the electromagnetic spectrums. Okay po? So we go back to our presentation. So yeah. So remember class that light is just a portion of electromagnetic waves. Okay, so visible light or light, so that pertains to the same thing, which in the range of 400 to 700 nanometer. Okay, so 400 to 700 nanometer in the electromagnetic spectrum. Beyond this one, or beyond this range, we cannot see a particular wave. Okay, so that's only a visible light. Okay, so saan ba nag-appear yung visible light? You can observe that in your surrounding, because you can see different colors, therefore visible. That's visible light. Also, the monitor of your laptop or cell phone, there is the presence of visible light, wave. Okay ba? So yan. What about the nature of light? So different theories were proposed to describe the behavior of light. So in 1600s, okay, so light is believed to have the stream of particles called corpuscles. So Newton believed that light behaves like a particle rather than a wave. So it's still a question as of now whether a particular wave is a wave or a particle. Okay? So Christian Huygens proposed that light behaves like a wave. Okay? So si Newton, according to Newton, it's a particle, but Christian says that it behaves like a wave. Okay? So let's continue. Okay, so Max Planck proposed a theory of dual nature of light. Okay, so when we speak of dual nature of light, it says here that light is both what? Is both a particle and a wave. So how does this happen? It's because of the experimentation of Max Planck. Okay, so characteristics of light. So remember class that light travels in a straight path. Whenever you have flashlight during the night, so kapag pinag-flash mo siya, so it's just a straight line. Hindi siya curved, di ba? Hindi siya curved, hindi siya zigzag. It's just a straight path. Okay? So shadows are formed when an object blocks the path of light. For example, there's a light here, and here you are, then you can see your shadow. Okay po, beyond you. Okay po? So, yan. So, shadows are formed when an object blocks the path of light. Okay? So, how do we see things? How do we see colors? How do we see our cell phone? How do we see our gadget or etc.? So, yan. It's because of the two terms that we're going to describe here. This pertains to reflection and refraction. So, we see non-luminous object. When we speak class of non-luminous, hindi siya umiilaw, di ba? For example, stapler, something. Things that are not luminous are the things that does not emit light. Okay? Pag sinabi nating luminous, these are the things that emit light. Okay? So, like sunlight, like flashlight. Okay? So, luminous objects can be termed as naturally occurring, like sun, like stars. Non-luminous objects are meron ding luminous objects na artificially made like flashlight. Okay pa? So, when it reflects light from the source and when these reflected rays travel to our eyes so that we can see non-luminous object. Because it reflects what? It reflects the light that comes from luminous object to the non-luminous object to our eyes. Okay, so that's why we perceive things. So remember that when you are in a dark room, there is no source, any source of light or kahit dim light, wala. You cannot see your cell phone. You cannot see anything because walang nagre-reflect ng light. But when there is a light source, for example, light bulb, you can see things na hindi mo nakikita. Okay? Or things that are non-luminous. Okay? So sources of light, so as I said, can be natural or artificial. Natural can be found in our environment, like sun. Sun is the natural source of light, or main source of light, especially in our solar system, in Earth. Okay po? Sun. Okay, for other galaxies, we have stars as well. These are luminous objects. Okay? What about moon? Is it luminous or not? Luminous or not, the moon? Hello? The moon during the night. Luminous or not? Do I still have a student here? Luminous. Luminous because it's glowing in the dark. But actually, it's not luminous. Okay? It just gets its light from the sun. Yeah, okay, so the moon just reflects the light from the sun, but moon isn't luminous. Okay po? So yan. So anyway, matatopic natin siya at the end part of our topic, yung different yung eclipses. Okay? So eclipses, full moon, half moon, madidiscuss natin yan at the end. Okay, but remember that moon is not luminous. Okay, it just reflects the light from the sun. Okay, so like bioluminescent objects. Okay, yung mga bioluminescent, meaning these are organisms or organisms that can emit light. Alam niyo yung fireflies. Okay, fireflies. Okay, so these are bioluminescent, meaning they can emit light out of their body. Okay po, or out of the parts of their body. Okay, so yan, luminous means it emits light. Non-luminous it does not, but non-luminous objects can reflect light. Okay po, so yan, these are the sources. Light bulb is an artificial one, which are man-made. Okay, so sources of light, objects that only reflect light from the light source for it to be seen are called non-luminous. Okay, so the very common objects that does not emit light, books, cell phone, yung cell phone pala nag-i-emit ng light. Other objects that does not emit light, you call that as non-luminous objects. Okay po? So, also with the moon is non-luminous. Okay? So, do not forget that. Okay? How do light transmits? Or how do lights transmit? So, transmission of light occurs when light wave passes through. Okay? Passes through, meaning nag-pass through siya sa object. Or bounces off. This is the light, it bounces off. Okay? Or absorbed. Okay? Absorbed by the object. Okay? So, there are different types of objects when it comes to the transmission of light. When we speak of opaque objects, these are objects that do not allow light to pass through. Okay? Ano ba yung mga object na hindi nag-a-allow sa light na mag-pass through? For example, wall. A wall is an example of opaque object. Meaning, yung kapag sa gabi, may ilaw sa loob ng room, sa labas hindi naman lalabas yung ilaw sa loob through the wall. Okay? So, opaque object. It does not allow the light to pass through it. Just absorbs the light. Okay? So next we have translucent. When we speak of translucent, these are objects that allow light to pass through them partially. When we speak of partially, not all, okay? Not all are absorbed. Not all can pass through, not all, some are absorbed. Okay po? So for example, ano ba? Example ng translucent is yung tinted glass. Okay? When we speak of tinted glass, only some light can pass through it. Okay? Some are minimized. Okay? So you call that glass as translucent. Yung mga yung mga tinted na halimbawa helmet. So hindi naman lahat ng light parang fini-filter out niya most of the lights na i-absorb or mag-reflect para hindi ma-absorb lahat ng light. Okay? So these are translucent objects. It allows light to pass through them partially. Translucent. Okay? Frosted glass. Okay? So is another example. Okay? Yung mga mga bintana nyo sa CR, frosted glass. Okay? Meaning hindi mo makikita yung pag tiningnan mo siya, hindi mo makikita kung ano yung nasa loob, pero yung light, parang may light sa loob. Okay, so ganyan yung example, yung nasa picture. Okay? Frosted glass. Common niya siya sa mga CR, sa mga bintana. Okay, mga ganyan. Okay? Frosted glass. Okay? So next, okay, transparent. Okay? From opaque to translucent to transparent. So what are transparent? These are objects that allow light to pass through them completely, like a glass. Okay? Eyeglasses. Okay? So pag eyeglasses, these are transparent, pero pag sunglasses, these are translucent. Do not forget that. Okay? So it allows light to pass through them completely. Okay? So halimbawa, yun nga, yung glass, makikita mo kung anong color nung nasa loob ng glass. Eyeglasses, makikita mo kung ano yung mata mo. Makikita ng ibang tao kung ano yung mata mo. Ano pa ba yung mga transparent? Plastic. Okay, yung plastic cover, cover ng sa libro. Okay? Kapag plastic cover, kahit siya may cover, since it's transparent, you can see or you can read the content of the book. Ano pa ba? Okay. So there are many examples of transparent objects. Okay, you can observe that. Basta remember that transparent, it allows object to pass through them completely. Okay pa? So let's talk about brightness of light. Kasi when it comes to sound, merong sound na ting ting, meron namang sound na ting ting, malakas. Depende siya sa intensity of sound. Same thing with also for light. Okay, so there is what you call intensity. Okay, pag sinabi nating intensity, gaano ba kalakas? Okay, gaano ba kalakas or kaliwanag? Wow, kaliwanag yung light source. Okay, and intensity class depends on what? Two factors. We have here the source, distance from the source, and the source itself. Okay? Distance from the source and the source itself. So, if you are going to notice, let's talk first about the distance. Okay? So, if we are going to observe during the night the stars. Okay? So, there are stars which are bright enough, pero since it's very far, hindi kaya natin siyang tingnan with our naked eyes. Diba? Pero if you're going to go through near them, dun sa malapit, hindi mo sila kayang tignan because mabubulag ka. Okay? So, distance is a factor that contributes to the intensity of light. Okay? So, yeah. So, make sure that you distance yourself from your monitor. Okay? So, kapag malapit, so it can affect your eyes more than malayo ka. So, dapat you distance yourself from the monitor. Okay? Because monitor emits visible light. Okay? So, what else? Okay, aside from distance, it's also dependent on light source. So, since star na rin lang naman yung pinag-uusapan natin, there are stars that are bright enough, Okay, compared to other stars. Okay? So, yung star natin, yung sun, is not bright enough compared to other stars. Okay? So, yan. So, depende kung gaano kalakas. Okay? For example, you have with you your phone. If taasan mo yung brightness and the other phone hindi, so it dependent. Okay? Source dependent yung brightness of light. Gaano ba kalakas yung kanyang ini-emit na light? Okay? I hope you get that. Okay pa? Nagas niya pa? Okay, so let's proceed. Okay, so brightness of light. So the nature of light as particle explains why intensity changes with distance. Remember before, according to Newton, that light, according to Newton, is a particle. Okay? Pero pinag-contradict naman siya ni Christian Huygens that light is a wave. Okay? So the nature of light as a particle explains why the intensity changes with distance. Okay? So yan. Okay? So the particles of light are called photons. Photons. Okay? So photons are closer at light source. Closer as at light source. Okay pa? So, yan yung photon. So, in this illustration, it shows that distance affects the intensity of light. Why? Because, according to nga kay Newton, it's a particle, it's a photon that is dependent upon the distance. So, here, we have different distances, A, B, and C. So, for A, yan. Okay? For B, dumadami. For C, dumadami. Okay? So, light particles spread out and becomes dimmer at a distance. Kaya bagay yung mga stars, dim lang siya. Okay? Dim lang yung light source niya. Pero kapag lumapit ka, it's very, very bright na hindi mo siya kayang tignan with your naked eyes. Okay? So, yan. Light particles spread out and becomes dimmer at a distance. I hope you get this one. Okay? So, how is light being dispersed? So, dispersion of light. So, dispersion of light, okay, it refers to the spreading of light into its color components. So, bakit kaya merong color? So, yan. So, mapag-uusapan na natin dito class yung color. Okay. So, it refers to the spreading of light into different color or bands of color. Okay? So, the different colors of visible light spectrum will form white light. Okay, the different colors in visible light spectrum will form white light. So if you're going to combine the different colors in visible light at an equal magnitude and frequency, you will come up with a white color. Okay, so yan. So what you can see here is a white light. White light is a natural light that comes from the sun. So, that passes through a prism. You call this one is prism. So, to be specific, it's a triangular prism. Okay? If you look at that, some light are reflected, kaya siya tumaas doon. Some light are refracted. When you speak of refracted, it bends toward the prism and it goes out of the prism with separated bands of colors. Okay po? So, white beam of light is separated into its different components. These are bands of colors. Okay? These bands of colors have varying degree. What are these degree? These are the frequencies. Okay? Question? Do you have any question? Parang wala kayong tanong Okay. So, when natural light enters a triangular prism, okay, the light emerging from the other side of the prism is separated into a continuous color red to violet. Okay, yung red yung nasa taas, violet yung nasa inner part. Okay? Red to violet, ito na yung Roy G. Biv. Ano nga yung Roy G. Biv? Red, orange, yellow, blue, indigo, violet. So, para hindi nyo makalimutan yung bands of color, you memorize Roy G. Biv. Okay pa? So, some other books, hindi na in-include yung indigo, pero some, they include it. Okay pa? So, next. Refraction. Let's talk about refraction. So remember, as I said before, earlier, that refraction pertains to the bending of light. Okay? Refraction as compared or as opposed to reflection, pag sinabing reflection, magba-bounce back. Reflect, bounce back. Pero pag refraction, magbe-bend. Hindi magbe-bend. Magpe-penetrate yung light pero magbe-bend siya. Magbe-bend. Okay? So, saan ba nagkakaroon ng Saan ba nagkakaroon ng refraction? Nagkakaroon ng refraction class sa mga transparent objects, sa mga translucent objects where light can pass through. Magkakaroon ba ng refraction sa opaque object? No, because opaque object absorbs light. It does not allow to penetrate the light. Okay po? So, yan. So, refraction. When we speak of refraction, it allows the bending of light. Okay? So, saan siya nagbe-bend? One example is water. Water is a transparent object. Okay? It's a transparent medium. Okay? So, refraction is the reason why the pencil looks bent in a water. Look at this one. That's because of refraction. Okay? You try this at home and you can see this one. So, paano ba nagkakaroon ng refraction? Refraction class happens when what? Okay? When the light passes through a different medium. When we speak of different medium, one is air, in this case, the other is water. Okay? Air yung nasa above layer ng water, and water yung nasa below ng surface. Okay po? So, nagkaroon ng different medium that cause the light to bend. Okay po? So, kasi iba naman yung characteristic ng air, iba naman yung density, iba naman yung characteristic ng water. Okay, in this case. But, that's a different topic naman. Okay po? Let's continue. So, refraction, the bending of light, is affected by the material's index of refraction. Every material, there is this presence of, or there is this index of refraction. The boundary between two materials where light passes through is the normal line. I hope. Okay, merong figure dito. Okay? So, normal line, index, wag pong kalimutan. Sorry, isa na tayo. Yan, index of refraction. Do not forget, that is constant to every matter. Okay? Normal line. Okay, look at this one. Light is bent downwards when it enters the prism. Okay? And downward again as it leaves the prism. Look at this one. So, where is the incident light? Incident light is the light that will pass through before the prism. Okay? So, incident light. So, remember, nagkaroon siya ng refraction. It's reflected or refracted, nagbend, naging straight line, and lalabas siya outside ng bend. Okay? Refraction occurs when light enters and exits the prism. Okay? So, a prism, meron siyang, depende yan. Kung yung prism mo is glass, iba naman yung index of refraction ng glass. Okay? So, the index of refraction of any material is dependent on the wavelength of light. So, as the wavelength of the light increases, the index of refraction of material decreases. Okay? So, yan. Okay? Halimbawa, nag-increase from red to violet. Okay? The index of refraction of the material will decrease. Okay? So, it will decrease. Okay? So, the refracted ray that leaves the prism will be diverged from its original direction, referred to as the angle of deviation. Okay? So, look at this one. The greater the wavelength of a given color, the less bending will occur. Alin? Among the colors, alin ba yung greater wavelength? Pag sinabing greater wavelength, mahaba yung pagitan from one crest to another crest. And that is the red color. Look at this one. The red color bends. Okay? The greater the wavelength of a given color, the less bending. Okay? The red color bends lighter. Pag sinabing lighter, konti lang yung angle ng kanyang ipinagbend as compared to the violet. Okay? So, itong violet, nag-bend siya ng madami. Okay? Yung red, hindi masyado. Because red has greater wavelength and violet has shortest wavelength. Okay po? Rays corresponding to the different colors are bent by the prism in varying amounts of angles. So, iba-ibang angle. Yung red, iba yung angle. Yung orange, iba yung angle. Lalo na yung violet, iba yung angle. Okay po? So, that's why different angles form different bands of colors. Okay? So, here, you can see from nature, rainbows. Bakit kaya merong rainbows? Do you have any idea why we do have experienced rainbows? Ano ba yung kantang yun? Nakalimutan ko kasi. Basta, from the lyrics of the song, it says that rainbows always comes after the rain. I don't know. Kung alam niyo yung kantang yun, sige nga doon. Ano nga yung tono nga nun? Yung ano? Basta yung sa lyrics, yun lang kasi yung natandaan ko that it is said that rainbows always come after the rain. So, something ganun. Hindi ko kasi alam yung kantang yun. Okay? So, bakit kaya nagkakaroon ng rainbow? Do you have any idea? Bakit kaya nagkakaroon ng rainbow? Okay. So, rainbow, trivia lang rainbow, it occurs during the day. Okay? Wala siyang night. Pero pag night, meron namang night, ang tawag dun class, moonbow. Pag merong rainbow sa gabi, moonbow, pero pag araw, rainbow ang tawag. Kasi dalawang factor ang meron kung bakit nagkakaroon ng rainbow or moonbow. One is the sun, the source of light, and the other is the rain. Or rain here acts as a prism. Okay? It refracts the white light, it passes through the rain droplets. Okay? Kasi umuulan, di ba? It passes through the rain droplets and it will refract light forming different bands of colors. Okay po? So, rainbows are formed by the dispersion of light in water droplets. So, droplets here in this case acts as what? Acts as the prism. Okay? Or the medium that bends the light. Okay? In the case of moonbow, perhaps, or I think it's the moon, the light of the moon that is the source of light. Okay pa? So, refraction occurs when the rays enter the raindrop, from air to water, different medium, and again exits from water to air. Okay pa? In this case, it forms in a curved line because it has different frequencies. So, rainbows, spectral colors can be observed because each color comes from different raindrops at different angles of elevation. Okay, so much for this one. Okay, so yan. I'm going to show you one video, why do we perceive colors. So this one is a very nice video that will explain how do we perceive colors, especially rainbows, since napag-usapan na rin lang naman natin yung rainbow. Okay? So, let me play this one. Can you see the video? Hello? Can you see the video? Okay? So, let me play this one. I want you to listen and understand what is the content of this video. Okay? So, yeah.
Light. It's all around us. But what is it? Where does it come from? And what does light have to do with color? Light is a kind of energy that travels in waves. It is made when matter is heated up or gains energy. Excess energy is released, in part, as light. This energy is called electromagnetic radiation. When we talk about light, we usually mean visible light, which is the light that we can see with our eyes. But there are more types of electromagnetic radiation that are invisible to us, including radio waves, microwaves, X-rays, and gamma rays. Scientists can detect and measure invisible radiation with special tools. Together with visible light, all these types of radiation are called the electromagnetic spectrum. All electromagnetic radiation travels in waves, but different types have different wavelengths. The wavelength of electromagnetic radiation, or light, is connected to how much energy it has. Light with a longer wavelength, like radio waves, has less energy, while light with a shorter wavelength, like gamma rays, has more energy. Visible light makes up only a tiny part of the electromagnetic spectrum, but it includes every color we can see. The most important source of light here on Earth is the sun. We call ordinary sunlight white light, but it actually includes all the colors of visible light. These colors can be revealed when white light goes through a prism. When light passes through a prism or something like it, it slows down a little bit and bends. Some parts of the light slow more than others, and the light spreads out into the colors of the spectrum. If you want to see all of the colors in the visible light spectrum, look no further than a rainbow. Rainbows are made when water droplets in the air bend sunlight much like a prism. Usually when we talk about a rainbow, we say it is made of 7 colors: red, orange, yellow, green, blue, indigo, and violet. Each color has a different wavelength. Red has the longest wavelength in the spectrum of visible light, and violet has the shortest wavelength. All the other colors have wavelengths in between the two. The colors of a rainbow are always in the same order, because the colors are arranged according to their wavelengths. Red is always on the outside, because red has the longest wavelength, and violet is always on the inside, because violet has the shortest wavelength. Electromagnetic radiation with a wavelength outside the visible light spectrum is invisible to our eyes. Light with a longer wavelength than the reddest red our eyes can see is called infrared light. Light with a shorter wavelength than the most violet violet we can see is called ultraviolet. When we look at an object, we are actually seeing the light that is bouncing off of it.
So our meeting is gonna end. So you should...
A green leaf looks green because the leaf absorbs all of the colors in the spectrum except for green, which it reflects. When the green light enters our eyes, our brain tells us it looks green. Things that look white are reflecting almost all of the visible light shining on them, and things that look black are absorbing almost all of the visible light shining on them. Light, both visible and invisible,
Okay, so... Ayun. So yeah, so it says there, how do we perceive color? Okay, so we perceive color because it's the color of the visible light or white light that is reflected, okay, that bounces off through things, okay, like for example, leaf, we can see green because it's the green color that is being absorbed by our eyes, okay. So some colors are absorbed by the leaf and green color is reflected, so that's why it reflected towards our eyes, okay. So at the end part of the video, it's also said that black color or black things absorb all the colors of white light or visible light or RGB, but white color reflects all the colors of visible light. So here we can apply the things. Okay, di ba kapag summer dapat ang sinusuot mo palaging white para hindi maiinitin, okay? Because it reflects all the visible light, okay, out of your shirt, white shirt. Okay, pero pag black yung suot mo, class, it will absorb all the visible light. That means all the energy comes from the white light, you absorb it. Okay? So that's why you feel na mainit ka. Okay? So may initin kapag black. So always white. Wear white rather para at least hindi kayo mainit, especially during summer. Okay? So yan, as I said, that's gonna be our final topic that we need to discuss. Thank you for listening into my discussion for today.